Okay, guys, so we are in a new section, 6.2a lesson, where we're looking at the perimeter and the area of polygons. Okay, this first activity below is an image of rectangle ABCD with dimensions 4 units by 6 units, as you can count in the little graph paper behind it. On the first grid provided, draw a rectangle with side lengths twice as long as this image. Label the new vertices E, F, G, H. And on the other grid, draw a rectangle with side lengths half as long as this image. Label the new vertices I, J, K, L. All right, so twice as long, we're going to do 8 and 12. So let me start here. Get a straight edge here. All right, so 1, 2, 3, 4, 5, 6, 7, 8. 12. I'll scooch it up in one sec, guys. I'm just getting it jotted down. All right, so this distance right here went from 4 to 8, and this distance right here went from 6 to 12. Okay, and they said to label it EFGH. So EFGH. Please make sure that A, B, C, D goes with E, F, G, H. The E goes with the A, the F goes with the B, the G with the C, and the D with the H. Okay. All right, now this guy down here on this one, we have to do half. So this one was twice, this one we're doing half. So if this was 4, we're literally doing 2. And then if this is 6, we're literally doing 3. 1, 2, 3. Okay, so let me get a straight edge here just so it's neat looking. All right, and we needed to label this one IJKL. So IJKL. And again, you're rounding it just like we rounded this one. The A needs to pair up with the I, the B with the J, the C with the K, the D with the L. Okay. All right, describe the method you use to double the length of each side. So I multiplied, scooch that up. I multiplied each side length by 2. Describe the method you use to make each side have a length half the length of the original. I multiplied each side length by a half. Do you think the area of the new rectangles changes at the same rate as the sides? Okay, so I don't think so. We're going to investigate that. Okay, the length and width change the area separately. The length and width change the area separately. Scooch that up. All right, this table on number 4 is key. You are going to see this table on quizzes and tests. Okay, so you need to make sure you understand this table. All right, so ABCD, this goes back to the very original pull it down just to remind you, this guy up here. Okay, so the dimensions are 4 by 6. Now remember perimeter from elementary school. Perimeter, you're literally counting the units around. Okay, so if you count around this thing, you're going to count 20. Remember, area of a rectangle is length times width or base times height, however you want to call that. So we get 20 for the perimeter, that's in some sort of units, and then the area is 24 units squared. Okay, now there is no change because it's the original rectangle. Okay, so you can either just put like a dash in there or write the word original. All right, now we're looking at the blown up one, EFGH. Okay, this is now an 8 by 12. The perimeter, if I count around this thing, the perimeter of this is 40, and the area of it is 96. Okay, keep in mind units and units squared, written just above here so we don't have to rewrite it every time in the table. Okay, now the change in the side lengths, 4 and 6 became an 8 and a 12 because we multiplied by 2. 20 became a 40 because we multiplied by 2 on the perimeter. 24 and 96, that one's a little bit more challenging. It actually gets multiplied by 4. Okay, let's do the smaller one. Okay, now its dimensions are 2 by 3. Its perimeter is 10, and its area is 6. The change in the side lengths, from the original, we're not comparing it to this row, we're comparing it to the original. So 4 became a 2, 6 became a 3. We multiplied that by 1/2. Okay, now it's really important to understand, think of it in terms of multiplying and not division. Okay, and then from the original perimeter to the new perimeter of the shrunken down object, we also multiplied by 1/2. Okay, and then from the 24 to 6, we're multiplying by 1/4. Okay, so something is definitely going on. Okay, now the activity 2 should be on the next page. Activity 2, below is an image of rectangle MNOP, which is 3 units by 6 units. On the first grid provided, draw a rectangle with side lengths 3 times as long as this image. Okay, so let me flip the page here. All right, so we need something 3 times as long. We're doing the same thing, but this time we're doing 3 times as long and 1/3 times as long. And then we're answering the same table or chart at the bottom. All right, so we've got 1, 2, 3. So we need 9. I wonder if I went down enough. I probably didn't. Let me go down here just in case. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6. It needs to be 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Glad I went down a little further. Okay. So ignore that dot here. I'm going to, in fact, draw a line through it here in a moment. This dot, I needed to go lower to count up 18. Okay, let me get those lines drawn in. All right, so we got this guy. Okay, and remember what I said about the labeling business. Okay, if it's MNOP, we need to label in order here, 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 here. So this is QRST. Okay, now 1/3, that's just going to be 1 unit by 2 units. I think I'm just going to freehand this one because this one's pretty teeny. Okay, and I'm going to go ahead and label U, V, W, X in that order specifically. All right, let's answer the questions here. So we have our 3x6 MNOP. The perimeter is 18 units. The area is 18 units. And this is the original. Okay, so you're either writing a dash in there or you're writing the word original. Okay, now the blown up version. The blown up version ended up being 9x18. The perimeter, if you counted around the whole thing, is 54. And the area, if you multiply the base times the height or the length times the width, is 162. Okay, now their original compared to this blown up version, we're multiplying it by 3. That's the change in the side lengths. The change in the perimeter, 18 to 54, we're multiplying it by 3 as well. Now 18 to 162, we're multiplying it by 9. Okay, now let's do the shrunken down version. Okay, so this is a 1/2. Remember, we're comparing it to the original one. We're not comparing it to the blown up one. Okay, this is going to be the perimeter 6 units and the area is 2 units squared. Okay, 3 and 6 changes to a 1 and a 2 because we multiplied it by 1/3. Again, do not say divided by 3. You multiply by 1/3. Okay, 18 to 6, you multiplied by 1/3. And then 18 to 2, you multiplied by 1/9. Okay, so you should definitely be seeing a relationship, maybe a shortcut perhaps, with what happens when you change the dimensions of the rectangle and how that affects the perimeter and how that affects the area. All right, next one is a little bit fancier because it's a triangle. Okay, here's an image of ABC triangle. On the first grid, the side lengths are going to be twice as long, and on the other one, they're going to be half as long. Okay, so if we have this one, and it's 8 units, we need a 16 unit. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 units. Okay. All right, now the height of this thing, remember we count right here. 1, 2, 3, 4. Well, the height has to be 8. The height has to be 8, so the height has to be, let me do that in pink, and I just lost it where it was. 1, 2, 3, 4, 5. The height has to be along here. But we're not sure where to put that vertice. Okay, well, here's how we're going to do that. So if this is 1, 2, 3, 4 up and 2 to the right, we better go 8 up and 4 to the left. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay, so let me say that again. We know that it's 4 height here, so it has to be 8 height here, but where do you put that vertice is the question. So if everything is doubled, if we go up 4 here, we need to go up 8 here. If we go to the right 2 here, we need to go to the right 4 here. Okay, so here's where we're going to be drawing our okay, and this is D, E, F. And this is, I'm just going to write 16 units in here. You didn't have to. Okay. Okay, we're going to do the same technique with this one. Okay. All right, if this is 8 units long, we want one 4 units. 1, 2, 3, 4. Okay, now the question is, where do we put that? Okay, we know we're going to be up 2 units somewhere. We're going to be up here, but we don't know where to put it. Okay, now if we go up 4, we better go up 2. If we go right 2, we better go right 1. So right there is where we're putting it. Okay, and then we're going to label that one GHI. And this is 4 units. All right, the method I used. Describe the method I used. Okay, the horizontal one was simple. This horizontal one, the horizontal side was simple to double, or half. All right, so, oh, this is just the double one. Sorry, guys. The half one will be down there. All right, so I noticed point C, vertex C, was up 4 and right 2 units. So doubling would be up 8 and right 4 units. Okay, similar for the half. The horizontal side, horizontal, was simple to half. I noticed C was up 4 and right 2 units. So halving, taking half of, I don't know if that's a word, okay, but you get what I mean. Okay, so halving would be up 2 and right 1 units. Alrighty, do you think the angles of the new triangles are the same or different than the original triangle? Okay, the angles are the same. The angles remain the same when you enlarge or shrink an object. Alrighty. Okay. What do you think will happen to the perimeter? Okay, when the sides of a shape are scaled by a factor. Remember, that factor could be 2, 3, half, 1/4, 1/3, okay? The new perimeter will also be scaled by the same, I'll put the same factor. Okay, you saw that in those tables. Let me go back to them. Okay, if the side lengths are doubled or halved, so is the perimeter. If the side lengths are times 3 or a third, so is the perimeter. Okay, let's talk about the area. When the sides of a shape are scaled by a factor, the new area will be scaled by the square of that factor. Okay, let me show you what that was when we did it earlier. Okay, when the side lengths are doubled or halved, doubled or halved, the area is by 4 or by a fourth. So we squared these. 2 times 2 is 4. 1/2 times 1/2 is 1/4. Looking at this one. When the side lengths were scaled by 3, 3 times 3, the area is a 9 scale factor. 1/3 times 1/3 is a 1/9 scale factor. It's squared. Okay. It's to the power of 2. It's not doubled. It's to the power of 2. Okay, it's to the power of 2 because you have 2 sides that are affecting it. Okay, so if this side is doubled or tripled, and this side is double or tripled, since area is 2-dimensional, okay, that would be a scale factor that you'd have to multiply for each of those dimensions. Okay, all right, let's look at this last activity here, activity 4. We will now explore the relationship between triangles that have the same angle measures but side lengths that are different. List the corresponding angles and sides in the 2 angles. Okay, so let's talk angles. Let's talk angles. So we've got angle RPQ. Angle RPQ corresponds to CAB in that order. Angle ABC corresponds to PQR. Okay, and the only one we haven't talked about yet is this QRP. QRP goes with BCA. Okay, let's talk about the side lengths. Okay, the side lengths RQ corresponds with CB in that order. Okay, you would not also say QR, QR corresponds to BC. That's the same statement. Okay, BA, it doesn't matter which triangle you start with and which triangle you end with. BA goes with QP. Okay, and make sure you have a little segment bar above saying segment. Okay, all right, and the last one we haven't talked about yet is RP and CA. RP and CA. Okay, those are corresponding angles and corresponding sides. Okay, describe how these triangles are similar and different. Okay, Is everybody noticing the angles are the same measurement? Okay, and the side lengths are similar. Okay, these side lengths are blown up by 3. These are shrunk by 1/3, depending if you're going from big to little or little to big. Okay, so the angles are the same, and the sides are similar. Similar means they're proportional to one another. Okay, what do you notice about the lengths of the sides of the two triangles? Okay, you should either notice the smaller triangles sides are 1/3 of the larger triangle. Triangle. Or you could also say the larger triangles sides are 3 times the smaller triangle. Okay. Wrapping up this lesson, guys. Similar figures. Figures that have the same shape but are not necessarily the same size. Sides are proportional and angles are congruent. Okay, so here's an example. A, B, C, E, F, G. This angle is the same as that angle. That angle is the same as this angle. And that angle is the same as that angle. Okay, the side lengths are not equal. So the way that it's symbolically represented would be triangle ABC is congruent to triangle or similar to triangle EFG. Let me make sure I got that in the right order. A, B, C, E, F, G, yes. Okay, congruent parts, angles or sides that match up between two shapes. The order of the matching matters. So here's an example. Side AC is similar to side EG. And I won't go through all of them. We did all of them on the last couple pages ago. Okay, let's do one of the angles. Angle CBA is similar to GFE. All right, and then these last 4 problems. Fill in the blanks to make each statement true. If the change in the dimensions of a shape to a new shape has a scale factor of 4, then the change in the perimeters would be a scale factor of, remember we said it stays the same, 4. If the change in the shape of a new shape, if a change in the dimensions of a shape to a new shape has a scale factor of 7, then the change in the shape's areas, remember we said we square that 7, so it'd be 49. If the change in the perimeter of a shape to a new shape has a scale factor of 49, then the change in the shape's dimensions would be a scale factor. Remember, perimeter and side lengths are the same. If the change in the area of a shape to a new shape has a scale factor of 36, then the change in the shape's dimensions would have a scale factor of, we need to think of 2 numbers that are the same that multiply to get 36, and that's 6. Okay, you need to understand these shortcuts. That was the point of this lesson. Okay? All right, guys.